Devel NYTProf. Okay, there are lots of Perl profilers that have been produced over the years, and they vary in terms of whether they profile subroutines or whether they profile lines, or really statements technically, but we'll call it lines. And all of them have had some kind of problems, and over the years the modules have got better, but still limited in too many ways. So now Devel NYTProf has joined the list. There's a couple of others there, but NYTProf is the one I'm going to show you today. It's the one that I think is the best. It certainly has the most glossy user interface. So we'll talk about subroutine profiling versus line-based profiling. Subroutine profiling is relatively cheap and gives you smaller data files because it's only doing anything when you call a subroutine or return from a subroutine. So that it's not involved, it doesn't interrupt the processing very often. The other big benefit of subroutine profiling is that you can measure the time spent in a subroutine, inclusive or exclusive of any subroutines that it calls. Okay. But the big problem with subroutine profiling in Perl is that Perl has lots of funky control flow. So for example, you can use next to come out of a subroutine. You can use goto to come out of a subroutine. So even the profilers that do the right thing for exceptions get tripped up in large applications because there's some module somewhere that does a next or a goto or a redo or whatever out of a subroutine. And because of the way the subroutine profiling works, once it's got confused, then everything is confused. Now in contrast, line-based profiling gives you very fine-grained details. It tells you how much time was spent executing each statement, which is typically a line. Now it costs more because it's interrupting the processing every statement, and also generates much larger data files. And one of the annoying problems with it is that it gives you very fine detail, and it's kind of too fine because often you want to know the subroutine level timing to give you a kind of first approximation. You can kind of look at it and say, yeah, that shouldn't be that expensive. Whereas if you're looking at line-based times, it's hard to see, it's hard to get a sense of whether those times are reasonable or not. Now, another thing you need to pay attention to when profiling is CPU time versus real time. Do you measure the time spent on the CPU, or do you measure the time spent waiting, the wall clock time? Now, most people think of profiling in terms of the CPU time. It's the default for most profilers, for most of the older profilers especially. And the idea is that it's not affected by load on the system. You're measuring the CPU time taken by your process. Now in practice it is a little bit affected by how busy the system is. But the big downside is very poor resolution. Now back in '95 when Devel DProf was written, 0.01 seconds was a long time. You didn't get an awful lot done in 0.01 seconds. But these days you get an awful lot done in 0.01 seconds. Another thing about CPU time is it doesn't show you how long you're waiting for things that aren't, well, waiting for anything that isn't waiting for the CPU. Now often in real world applications, you're more interested in where the program is spending time, irrespective of whether it's waiting for the CPU or waiting for disk or waiting for network or waiting for database, whatever. You want to know where the time is being spent. Okay, so you might have a really fast program, sorry, you might have a really slow program that shows up no bottlenecks when you look at the CPU time, but if you look at the wall clock time, you see the real bottleneck is that it's doing slow database requests. Yeah, that just wouldn't show up if you measured CPU time alone. So real time is much better, much higher resolution, and it's measuring the thing you really care about. Most of the time you don't really care about CPU time, you just want the program to be fast, you want it to do its job quickly. Now, Devel DProf is the kind of it's the default profiler that most people use. It's the kind of the knee-jerk profiler. You need to profile something, Devel DProf. And it was the best there was back in '95, '96, back in the 1990s. Oh, that sounds very old, doesn't it? But it's practically useless now, and it's practically useless because not only is it limited to the 0.01 resolution time for CPU, it artificially limits the resolution of the real-time measurements to the same 0.01 seconds. Now, just to demonstrate what happens, I should explain about the 0.01 seconds. The Unix kernel counts CPU time in jiffies, and a jiffy is normally 0.01 seconds. So that's its unit of accounting. If you ask the Linux kernel, how much time have I used so far in this process? How much CPU time? It'll give it to you in a multiple of 0.01 seconds. So what happens if you're running a very fast program is that those little ticks where you tick over from one 0.01 second to the next one can happen basically at random. So see this little script here, it writes a program with 1,000 subroutine calls and calls each of them once. So every subroutine call should take about the same length of time. And inside the subroutine it just does 100 square roots, just for the sake of doing something. So then we run Devel dprof, and we look at the output. Now you'd expect all of the subroutines to use roughly the same amount of time. What does Devel dprof show? 4 of them, according to Devel dprof, used 0.01 seconds, and the rest took no time at all. And even if you add up the percentages, it doesn't make sense. It's just broken. You know, it's not worth using unless you have some really slow program that just laboriously spends a long time in every subroutine that you care about. Then it's okay. But for most programs, Devel dprof is effectively broken these days. And it's broken really because the CPUs have got so much faster than they were 12 years ago. Okay. So let me sell NYTProf to you. It's a line-based profiler, but it's implemented in C to be very fast, to be as lightweight as possible. It also supports subroutine and block profiling, which I said line-based profilers couldn't do, but NYTProf does some extra work to dig back up the call chain, up the internal data structures to see what block and what subroutine it's been called in. So although it's measuring at each line, it can account for the time at the block or subroutine level. Very fast and accurate. Has an extensive test suite, which practically none of the other profilers do, and it's one of the reasons that I started putting a lot of work into it. Also has a very compact data file, so every sample only takes a few bytes, and it supports multiple report formats, and I'll show you the sexy HTML shortly. Oh, in fact, I'll show it to you now. Okay. Here we go. So this is an example output. Here's your program down the line side here. And beside it, you can see the measurements. So it executed this statement once, this statement once, this statement once, twice here, 2,000 times here, etc. The time it spent on that line, and then the average time it spent per call on that line. Does all that make sense? Now the color coding is based on a sort of statistical analysis of the profile of the numbers in each column. So it automatically adjusts relative to what's going on. So this is kind of the glossiest user interface. Now that's fine, but it's kind of not as useful as it could be. So what we're going to do first of all is, here I'm doing subroutine-based profiling. So what I'm doing is I'm accounting for the time of each line. I'm accumulating the time at the first line of the function. Hang on. There we go. So that's line-based, that's statement-based. Does that make sense? So you can see you're rolling up the times there and rolling up the counts. Now this is a great way to start profiling because you can home in on the functions that are taking longer than you thought, and then you can zoom in to the fine detail. But there's a problem with the fine detail. For very large functions where you have lots of loops, for example, it's still hard to drill down to find out where the time's being spent. So for the first time ever, in any Perl profiler, NYTProf now supports block level profiling. So you see here, it's accumulated the time spent in this block to the first statement of the block. So you can see there. And up here is all the time for this subroutine that isn't accumulated elsewhere. So that's all the time except what's listed here. So if you can imagine a large subroutine with lots of loops, this is showing you how long is being spent on each loop. I think you'll agree that's useful. Yes? Nods? Great, thank you. Okay, now, that's fine, but it's still not enough. It's not enough, I tell you. Because having used this tool and tools like it to optimize a 100,000 line code base, you realize it's not enough. Because you need, once you've made a subroutine as fast as a subroutine can be, just by looking at the code and saying, well, that's not very good, I need to tweak that because it's doing it slowly. You need to work out why the subroutine is being called so much. You know, there's two ways to make something faster. Either you make it run faster, or you do it less often. And most people, when they're profiling, just concentrate on the make it run faster, make the code faster. And they don't think enough about making it run less often. Why is this subroutine being called 20,000 times? You know? And in order to work out why it's being called 20,000 times, you need to know where it's being called from. And working out where it's being called from used to be really painful. You'd have to dig around in call trees and things. So, what I was up till 3 AM hacking on last night was this. So this is the same program, but what you've now got is extra annotations added. So here you can see this add is called one time by this benchmark. Don't worry about this weird file name here. It's just because benchmark happens to call this function from a subroutine compiled by an eval. Let's take a look down here. So this foo function, you can see it's called one time by main add and one time by main inc. And it's showing the line it's called at. So if I click on that, there we go. That's better. So line 7, boom, jumps to the foo up here. Let's look at this one. So here is a call to wanted using this callback. And here you can see that this wanted was called 315 times at file find dir line such and such. Now if I click on here, it takes me to, come on. It takes me to the right line. Laptop's a bit slow. Ding! That is magic. That will let you see the context in which something is being called in a large code base many times faster and with much less pain than you used to be able to see. So here you can see, looking at this, normally if you looked at that line, you wouldn't have a clue what that's calling. But now it tells you. It called main wanted 315 times. And if it called a bunch of different functions, you'd see them all listed here. And then, see, that's a link. Bang. Takes us back to what it called. So now you can drill up and down the call tree and see exactly where the time is being spent and why it's being spent there. Why was it called 315 times from here? Or 77 times from here? Let's go and look. Chug, 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 chug. It's a big HTML file. Ding. So, well, look, unless by depth and da-da-da. So you can look around, see what's going on. Okay. Let's go back. Ding. Okay. Any questions about that? Do you agree it's useful? Yeah, yes. One really firm yes. Yes, I want this. Okay. Hasn't been released yet, needs a little more polish, but it'll be out within a couple of weeks, I'd say. Certainly it'll be out by OSCON in July, because I'm doing I hope to be giving a lightning talk demonstrating it. I'm going to have to talk fast, because that's just 5 minutes.